Okay, so we've got this quandary. And the quandary is that we've got this object here. We've got 7 newtons this way. We've got 3 newtons this way. Okay? And I think everybody got that the net force is actually 4 newtons. Did we figure that out? Yeah, the net force is 4 newtons. So 7 newtons that way, canceled out by 3 newtons this way, is 4 newtons of net force that can cause the acceleration of this block. And 4 divided by 5 is 0.8 meters per second squared. Did we get that? Yeah. So here is how we solve all of these. Okay? The first step is to solve for / label all forces. Now, these forces we don't have to solve. They're just given to us. These forces that we're given are the 7 and the 3, and there's no solving there. But later on, it's going to be more tricky because you're going to have, like, one of the forces will be the part of gravity that's acting down a plane, right? Or one of the forces will be the force of gravity acting down on this, and we have to calculate that. Okay? So later on, this gets more difficult. The second step, can we be quiet, please? The second step is to set the vector sum of all forces. Set the vector sum of all forces equal to m times a. Yeah? So basically what we're going to do, this is going to look like for us plus or minus the first force, plus or minus the second force. Maybe if I'm on a roll, I might have 3 forces. Sort of my greatest desire to have like 4 different forces or something like that. Some of them you have to calculate. All of them you have to decide, are they positive or are they negative, right? And then you set those equal to m times a. Now a is either, well, a can be positive or negative, right? Okay, so a can be positive or negative. Each force that you possibly have could be positive or negative. And you've got to look at the problem. It's no longer plug and chug. You've got to look at the problem. You've got to understand, is it to the right, is it to the left? By the diagram, by the way it works, right? So we're sort of going into a new realm of problems, right? It does get a little bit harder than what we've done, which is good because, I think this class, I believe, had, quite a number of perfect scores. So, we got to tame that down a little bit, right? Okay. Mass is pretty simple. If the mass is in grams, turn it into kilograms and you're good. Right? It's always positive. So for this problem here, I'm going to decide that to the right is positive. Okay? Now, once you're done with the problem and you get an answer that's, say, positive, for example, you need to tell them that to the right was positive, that's your convention. Okay, so I'll show you that in a sec. So to the right, I'm going to make positive. That makes that a positive 7, but that a negative 3. Right? The vector sum of all forces is positive 7 minus 3 equals 5 times a. And then we get 4. And then, the last step is do math. I forgot to say that. Solve. Right? Okay, so now we have 4 equals 5 times a. And then a equals 0.8. Ta-da. So schwer ist es nicht, ja? Yeah. That's not so bad. Is that bad? Okay. So that's what we're supposed to do. Let's go. Let's do the next example. The next example is. Let's see. There we go. Not that one. There we go, this one. Okay, so now let's do one that has an unknown force in it. Let's solve that. So basically, by the way, the unknown can be one of these forces, right? It could be the mass. That's actually fairly difficult in some problems. It could be the acceleration. So we did one with acceleration. Now let's do one where there's an unknown force. So in this problem, we've got 35 kilograms. We've got a force of 450 newtons acting on it, but that is not the only force. there's a mystery force. I'm going to put it here. I'm going to say, I don't know which way it is. It's the mystery force. Could be to the right, could be to the left. Okay? And this thing is accelerating to the right. Okay? It's accelerating to the right at 9 meters per second squared. Now, we could scratch our head a little bit here and just sort of think about this and go, gee, I think I know which way this mystery force is acting, and here's what you could do, right? If there were no other force, isn't 450 divided by 35 a number bigger than 10? Yeah, is it accelerating that fast? No. So therefore we know, by somewhat of a roundabout way, that we know that there's got to be some force acting this way, right? Some sort of retarding force that's making it not accelerate as fast. Yes? Okay? So, but the method I'm going to show you, this is going to just fall in your lap. You're going to be like, look in your lap, and there it'll be, right? Okay? So let's set it up, right? Let's make to the right positive. Right is going to be positive. Okay? So this is a positive force. Unknown forces always make unknown forces positive because it's too confusing to make them negative. Okay? So I'm going to say that the forces, the sum of the forces is 450, which is positive. I know it's positive. It was given to me. It's to the right. It's positive. I'm positive that it's positive. Right? Okay? And then I'm going to say plus F. Now, even though I know that that force is to the left in my intuition, right, I make it positive because the math will make it negative. Okay? And then I say that equals 35 times positive 9. And I know that 9 without the positive is still positive, but I'm just saying I've consciously decided that that 9 is positive. It's in the positive direction. I'm going to give you accelerations that won't be to the right. You'll need to make them negative. Okay? So now we just do math. We've done it. We've done the vector sum of all forces. We just need to do a little bit of math. Not too much math, because that would make us sad. So 35 times 9 is 315. Right? And then I'm going to subtract 450 from both sides. And I get that F equals... Now, if you're one of these people that does math willy-nilly, and you don't keep track of minus signs, become that person that keeps track of the minus signs, because it is my goal to make a problem so sophisticated and so subtle that you can't just eyeball it and know that the force is negative, that you're going to have to rely on your ability to keep track of positives and negatives and trust in the math. Yeah? That's my goal. I've written pages of these problems. Okay? So you've got to go through here, and then you say, okay, that force is negative 135, so you have to say 135 newtons to the left. Right? Why do I have to say to the left? Because that's the way it is, and not everybody makes to the right positive. Isn't that right? So on an IB test, if you do this whole thing with a convention, make sure you either draw a picture about which way the force is, right? The force is that way, it's 135 newtons, right? Okay? Or you say it's to the left or something like that, because not everybody gets down into your mind and knows which way you've made positive or which way you've made negative. It might be a word problem, and there's many ways to draw it, right? So, I don't know. You guys ready to try? Yeah, you are. You think you're not, but you are. So here's that first one that we did. You guys already knew how to do that, so let's try. I bet you can't do this one. Oh my gosh, it's got 3 forces.
Why does it have 3? Like, wouldn't you just cancel out the 3?
Smack talking my problems.
Sorry.
Yeah, these are easily added as like scalars, right?
Like, do you add vectors?
Yeah, sure. You're going to add these like vectors, right? But yeah, you could just add the 3 and the 6 without any reservation. Do this on a whiteboard. Show me the answer on a whiteboard.